Hi, grade 11s. Today we'll be looking at the sine function. You did this last year, but we'll refresh each other so that you can proceed next time we meet with the other functions. This is an example. It says sketch f of x equals sine x. When x is an element of 0 degrees to 360 degrees. So I've got to sketch the graph of sine x here. So this is just a refresh so that we remember how to sketch functions. So sine x can be sketched using a calculator so that you can get the values. How do you do that? So we go to mode button and then you check on the table. In mine it says 7. To some it could be 3. So there's 7. So number 7. Then it says f of x. So I need to type in f of x equals sine x. Then I go sine x there. The sine. But now I need to put in x. X is this x here, not the times. So the x, so I go alpha, then x, then I close the bracket. So f of x equals this. So when I say equal to, it shows g at x, but it's only one graph that I want. So I'll ignore this and then I'll say equal to again. Then say start. Now to start means that where is my graph going to start? It will start at 0 and end at 360. So it starts, so I'll have to enter the 0 equal to, and then it ends at 360. So 360 equal to. Now it's asking about steps. The steps, basic ones that we learned, were 90s because these are skipping in 90s. That's 90, 180, 27, 360. So I put 90 equal to. Now it gives me the values there, meaning it's giving me the points. So the first point there is as 0 is to 0. When x is 0, y is 0. 0 is to 0 is the point over here. Then the next point is 90 is to 1. And 90 to 1 is a point over there. The next point is 180 is to 0. 180 is to 0. Now I need to scroll down so that I can see other points. The next one is 270 to minus 1. 270 I go to minus 1 over there. Then the last one is 360 to 0. Is 360 to 0 is a point over there. So if I were to join these points of ours, not using a ruler but by freehand, shows us like there, something like this, then going to the next point over there, and then to the next one, form something like a wave. So this is a complete graph. And then you recall that you must always give the coordinates of the points that you use. So it's 0 is to 0, 0 degrees there, and this one here is 90 degrees to 1, 90 degrees is to 1, and this is 180 degrees is to 0, and this one is 270 degrees is to minus 1, and that one is 360 degrees is to 0. Then you're done. But the next question here says, what is the domain of this graph? Remember what its domain is. It's the x values that the graph can take. This one is taking the x values from 0 all the way to 360. So therefore we'll say x is an element of 0 degrees all to 360 degrees. What about the range? The range are the y values of the graph. The graph is starting at minus 1 all the way to 1. No gaps. So y is an element of minus 1 all the way to 1 on top. Let's look at another example. Now in this case, they've drawn the graph here. Y is equal to sine x. Now they want us to draw or sketch the graph of 2 sine x. So to sketch the graph there, we don't need to use a calculator all the time. You can see that this is y is equal to sine x. Now they want us to draw the graph of y is equal to 2 sine x. So it will be g at x is equal to 2 sine of x, which means that this graph here has been multiplied by a 2. But this graph was y, so the y values are multiplied by 2 because this was y. So the y values will multiply by 2. So if I were to multiply the y value here, because this is 0 is to 0, if I multiply y by 2, so the point will be 0 is to 2, so it still be a point over there. If I multiply here the y value by 2, the point would be 9:2. 9:2 is the point over there. If I multiply the y value by 2, it will be 180:0, still there. If I multiply this one here, the y value by 2, the point will be 270 to minus 1, 270 to minus 2, 270 to minus 2, we point down there. If I multiply this point here, the y value by 2, it will be that point over there. So my graph there starts there, it goes up high to that to there, and then comes down like this to that bottom one over there, and then it goes like that. So we call this a vertical stretch of the graph. Now we've drawn the graph. You must remember that still you have to put the points there that you've written, you've used it there. So that's 90 degrees is to 1. So this one is already there. So this would be 270 degrees is to minus 1. Minus 2. It's just 2 there to minus 2 down there. So what is the questions? The questions that they're asking, what is the period of this graph? The period is how long is the graph of G, the new graph which is green. How long is it? It's the length of this graph is 360 degrees. The next one, what is the amplitude? How do you work out the amplitude? To work out the amplitude, you take the top y value, you subtract the bottom y value, so I'm subtracting the minus 2, and you divide by 2. So your answer will be 2. That gives you plus 2 over 2, and your answer is 2. Let's look at another example. Again, you've drawn this graph here. And note that you may not be asked to draw a graph when you are given. You may be asked to do other things, right? Let's look at this one here. So already this one is drawn. Now they want us to draw the graph of g at x is equal to sine x plus 1. Now in this case, you can see that this is sine x. Now they want us to draw g at x is equal to sine of x plus 1. So in this case, what have they done to this graph? To the y value, they add 1. So each and every y value, we will add 1. So there is the y value. We will add 1. If we add 1 on this point here, on the y value, the point will be 0:1. And 0:1 is the point over there. If we add 1, because they said we must add 1 again. So if I add 1 to the y value, this would be 9:2 now. Because I have 1 plus 1 is 2. This 9:2 is there. The point is up there. If I were to add 1 on this point here, on the y value, so this would be 1:8:1. 1:8:1 is up there. If I add 1 on the y value here, so minus 1 plus 1 would give us 0. So the point would be 270 degrees is to 0, is the point over there. If I were to add 1 there on the y value, it means that it would be 360 degrees is to 1. So the point would be there. So I've got the points there, which I can join now, going up to there, and then going down like that, and like that, and like that. You can see now that this graph is not the same as this graph. This one was stretched. We call this one here a vertical stretch. A vertical stretch. All right? By a factor of 2. Factor of 2. Now, when you look at this one here, it's not stretched. We just shifted it by 1 unit. So this will call it a vertical shift of 1 unit, but going up because I can shift it down by 1 unit. Okay? Now let's look at another last example. So this last example, they say on the same axis, sketch g at x equals minus sine x. So this is a sine x. The original one, which is red, is y is equal to sine of x. Now they want us to draw the graph of g at x is equal to minus a sine x. So what have they done? They've multiplied the y value by a negative sign. So each y value will be multiplied by a negative sign. So if I were to multiply the y value here by a negative sign, or negative 1, so 0 multiplied by negative 1 is Still is 0, so a point will have there. So this one here, the y value will be multiplied by -1. So this will become 1 times -1, which is -1. So the new point is 90 to -1. So 90 to -1 is a point over here. If I multiply this one by -1, I get a 0, because 0 times -1 is a 0. So the point is still there. Come to this one. Multiply the y value by -1, because they said we must multiply by -1. So I get 270 to 1. So I've got a point over there. If I multiply this one, the y value by -1, I'll get 360 is to 0. So now the point is this. So we can see that the graph is doing this, and then goes like that to there and comes down there. And then I've got the new points here. So this is now 90 degrees is to -1, and that one now is 270 degrees is to 1, and that is 360 is to 60. You can see here, if you look at this one here, it's as if the graph has been turned like this. We call this a reflection about the x-axis, because I'm looking like I'm holding on the x-axis here. So you call it a reflection about the x-axis. So let's write it down. So this one here is a reflection about the x-axis. We will continue at some stage, and then we'll reflect this maybe about the y-axis like that. So on your own, ladies and gentlemen, can you try and do this work from your Siyavula Maths textbook of grade 11, chapter 5, says functions. You do 5.5, the sine functions, exercise 5.20. That's all. Good luck, ladies and gentlemen.